we'll do. You should be thinking somewhere along these lines. Now notice, Justin did this. Never put anything on the bottom of the fraction when you first do it. Okay? Unless it didn't have anything to go by. I shouldn't say never. There's cases when you do, but if you're watching. So what's x to the 2 minus 1 reduced to? X. Y to the negative 1 minus 4. Y to the negative 5. And then z to the positive 7, because those become positive. So what's wrong with that answer? The negative 5 power needs to go to the bottom, so we get x z to the 7th over y to the positive 5th. You got cards, show me how'd you do it. If you have a card, some of you might not.
I got it.
Here you go. No, ooh, a couple big. Those of you that are reds, what do you think? Get it fixed as we went through here, or still confused? What part still confused? The first part where we divide. Remember, this is just a division rule from yesterday. Division with like bases, we subtract. Are you right with that part of it? Okay. So.
Wait, when you subtract from here, they go to the x first.
What do you mean, where do they go?
Like, where does that x go? Like, does it go on top or bottom?
All of them go on top. When you're doing this division, they all go on top. Now, the only, I said there as I was kind of trying to explain that there are exceptions to that. And that would be like this. If I had an A down here, let's say, for instance, there's an A there, okay? Is there any A's up top? So you can't do any subtractions. So you're going to leave it on bottom. It's not going to move. It doesn't move. But if you're going to do a subtraction, put it on top. You'll get better at it, and you won't even have to put it on top. Like this y right here, when I would do that subtraction in my head, I'd be like, y to the negative 5th. Oh, I can't have y to the negative 5th, and I put it on bottom as y to the 5th. You'll get better at them as you do them. The more you do, the better you get. We'll see if we can, hopefully. Try this one right here. This is the quotient to a power. Now the bottom. This is the rule. This is the rule you got to follow. Yeah. Just a reminder of the rule. Shouldn't be too bad. Should be pretty quick. What do we get? 4 to the 3rd over x to the 6th. 4 to the 3rd we know is 64 over x to the 6th. Not bad. What if I do this? One little change will stump you. Maybe. Maybe.
Will we have to figure out like 4 to the 3rd, put 64 right there? Like we would do that, and you just said wrong one.
No, no. I'm tweaking calculators.
Right. But wouldn't it be your first answer? Split.
Not quite the first answer.
We should just switch them back like that. Like you put down the heel chest,
Yeah. What we got? What do you think? What did you do? How'd you do it? How'd you do it? I don't want to answer. I want to know how you did it. There's 2 different ways you can approach this problem. Okay. The old distributive. You can still do that. Even though it's a negative power, you get 4 to the negative 3rd over x to the negative 6th. But then you've got both negatives, so you basically switch them around. You get x to the 6th over 4 to the 3rd, right? And that's x to the 6th over 64. What?
But you could just keep 64 up there. Yeah, clicking the x to the negative 6 up, and then it'd be 64x.
No, because the 4's got a negative on it too. Can't have negative exponents, even with numbers. Can't have them. Here's the other way you can do it. Not distribute. Some of you may like this. If you like that, do it that way. I don't care. This is just another way you can do it. You have a negative exponent out here. All right, what does that mean for a fraction? What's a negative exponent do to a fraction? It flips it over. So flip over everything on the inside and make it a positive 3. Now you don't have any negatives to deal with at all.
I like it.
So that's the other way you can do it. And you get x to the 6th over 4 to the 3rd. Yeah. And that's the same thing. So it works both ways. I find this way will be less confusing because you don't have all your negatives. You guys hate negatives anyway. You end up screwing up some signs here and there. So just watch that. Let's try this one and this one real quick. See if you can get those. Right. Oh, man. Oh, man.
That's a little call. Never mind, I'll just make a mistake. But we don't have to do number 17, but 32. Never get 50.
What do we get for the first one? How'd you do it? Which method? Did you do the distributive method? She distributed the negatives, that's fine. So we'll do that one this way. So we get 3 to the negative 2 over 5 to the negative 2. Right, Kelsey? And then what? Basically flip it around, right? The 3's got to go to the bottom, 5's got to come to the top. So we get 5 to the 2 over 3 to the 2. And then you get 25 over 9. Those aren't hard to do. 25 ninths. And it should go that way either way. Now let's do this one the other method. We got a negative exponent. So you switch them to start with. M over 7a to the positive 2. And then you distribute your power and you get...
N squared over 49a cubed.
Good. You distributed 7. You said 7 squared was 49. That's fine. A to the what? A to the second power. Always check at the end for 2 things. Make sure you don't have any like bases left. Do we have any like bases in this one? And also make sure you don't have any negative exponents. Do I have any negative exponents? Yes, no? No. So if I don't, then I'm in good shape and I can quit. If I do, boy, I got things to worry about. Okay. I think that's enough. You guys got the right